What we're doing is a long-term research project on golden eagles. We started testing for lead in 2007. We're able to test the birds for a whole suite of heavy metals. The primary one that we're looking at, though, is lead. There has been numerous studies on eagles, bald eagles, golden eagles, great work on ravens, California condors, waterfowl, more recently mammalian species that have been found to be contaminated through scavenging of hunter-killed animals that are using lead-based ammunition. These birds have lots of opportunity to pick up lead along their migration. Big game hunting is going on. Caribou hunting in Alaska and certain provinces of Canada have almost year-round hunting. Our birds are on the move, and so they're picking the lead up while migrating. All the evidence points to that they're getting that lead from hunter-killed ungulates. They're dressed out in the field. The gut or the offal pile is left behind for scavengers to feed on, and golden eagles, even though they're amazing hunters, they're also opportunistic, especially while on migration. In the spring on the Rocky Mountain front, researchers have found that these eagles will respond to shooters that are out there shooting ground squirrels. They're looking for the meal as a response to the sound of the rifle shot. And a gut pile, perfect thing to feed on. Some of them are becoming contaminated with lead due to the fragmented rifle bullet in the offal pile. These birds, we capture them during their peak migration, process them, as we say, a series of morphological measurements, blood samples, feather samples, and cut them loose usually in about an hour. Some of these birds we know through satellite telemetry and isotope studies are coming from as far north as northern Alaska, Yukon territories, and then others are mid-latitude and lower latitude British Columbia. That migration bottlenecks or pinches off at our research site. What we're trying to do is get a representative sample of that entire migratory population. We take a blood sample from the bird and we bring it to Heiko's analytical lab here at the University of Montana, and he runs it through a series of tests.
We analyzed lead in blood samples of 178 golden eagles over the last few years. Turned out that 58% of them had above background lead levels in their blood, and 10% of them must be considered clinically exposed, and 4% think of as lethally exposed.
What we have found is that over roughly 60% of the birds we are sampling have elevated lead levels in their blood. This is a snapshot of that bird's blood lead chemistry at the time of capture, but what it suggests is that majority of this population of these migratory golden eagles are carrying elevated levels of lead in their blood.
And it looks from our samples that it doesn't take very many particles for lead levels to rise in the blood. This lead gets digested, so it gets taken up into the bloodstream. Bone minerals will absorb lead, and as that bone tissue gets rebuilt, the lead will get released back into the bloodstream, and they will never go down to pre-exposure levels. Lead, very toxic. There's really no safe level of lead. A deer that got shot with a lead bullet contains between 100 and 200 lead particles.
We know lead fragments permeates meat up to 2 feet. We know that scavengers that are eating that are being poisoned. We know the gut piles are riddled in lead. Even one small fragment in the digestive system of the eagle can outright kill it.
The metabolism for lead in eagles is fairly similar to humans.
Effects of lead has been documented. Low levels can impair motor skills, cognitive ability. In the case of an eagle, it could be the difference between an eagle being able to catch a jackrabbit and not. In higher doses of lead poisoning, we see renal failure or kidney failure. You'll see wing droop at that stage. The birds are acutely poisoned. For golden eagles, what we're observing is a 30 to 50% decline in the number of observed migrants over the past 15 years. What can we do to offset that? Lead is fixable. If hunters make the switch to using non-lead alloys, we're going to take that threat out of the wild.